Welcome to the fourth and final day of Math Boot Camp. Today we will have a variety of topics, including an Algebra 1 review and working with the calculator. Our first topic of discussion for today is a very brief trigonometry review. We're going to keep it brief today because we will look more at trig later on when we need to use it. The first thing we need to remember from trigonometry is the Pythagorean theorem, which says a squared plus b squared equals c squared, meaning that the opposite side squared plus the adjacent side squared has to equal the length of the hypotenuse squared. Another thing we need to remember is SOHCAHTOA. Okay. SOHCAHTOA stands for sine equals opposite divided by hypotenuse, cosine equals adjacent divided by hypotenuse, and tangent equals opposite divided by adjacent. Remember that the symbol for angle is a Greek letter called theta. It is not the circle with a line through it. It's not that funny O thing. It is called theta. Okay? And anytime you see this symbol, remember that it's theta and it stands for angle. Okay? So if we look at a diagram here, assuming that we're looking for the lower angle, I have labeled what would be the opposite, adjacent, and hypotenuse. If I were to change and look for the other angle in this triangle, I would have to switch the opposite and adjacent sides, because adjacent means that it's touching. This side does not touch this angle. However, the hypotenuse will always be the longest side of the triangle. Let's look at an example. This question asks, which trig function would you use to find the missing side in this triangle? So we have to first look at what angle we're given and determine which side is opposite and adjacent, as well as the hypotenuse. Let's start with the hypotenuse because it's the easiest. We know the hypotenuse is always the longest side of the triangle. So that means this side labeled 10 meters has to be the hypotenuse. Okay. So if I look at the other ones, if I start at the angle and draw a dotted line going away from the angle, then that side is the opposite. So this is our opposite side of the triangle, which means that the one that's left has to be our adjacent side. Okay. So we're looking for x, the opposite side. Based on SOHCAHTOA, oops, if I can spell. Okay. We know the hypotenuse. So therefore, we can automatically eliminate tangent because we don't know anything about the adjacent side. Okay. Next, let's look at cosine. This involves adjacent and hypotenuse. Well, the one we were asked to find is the opposite. Therefore, we don't want to use cosine either because it doesn't involve what we're looking for. That means we have to use the sine. Let's take this problem one step farther and actually solve for the length of the opposite side. I know that the sine of theta, which is our angle, so 45, is equal to x divided by 10. In order to get rid of this fraction, I'm going to multiply 10 to both sides. Okay, and when I put this in a calculator, I get that the sine of 45 is 0.707 multiplied by 10. So x equals 7.07 meters. Next, we're going to look at the classroom calculators that you have been provided. On the picture of the calculator on the next slide, I want you to identify 3 different buttons. The first button we're going to identify with the color red, and that's the square root button. The next button we're going to identify is the exponent button, which has two capital E's on it. And we're going to color that button blue. And then the third set of buttons that we're going to identify are all three of the trigonometry functions. Okay. If you are having trouble locating the buttons mentioned on the previous slide, I have labeled them for you. Again, blue is the exponent button. This is for when we have things times the power of 10. Say we're putting in 3.5 times 10 to the 5th power. We would press 3.5 EE5. Okay. If we use the EE button, we do not also use times 10. Okay. They mean the same thing, they're just a different notation. The next button I asked you to identify is the square root sign. On these calculators, you put in the number first. So say we want to take the square root of 700. We would put in 700 and then press square root. Next is the trig functions. I've labeled all three of them together, the sine, the cosine, and the tangent. It is not sin, cos, or tan. It is sine, cosine, and tangent. Okay. And these work just like the square root button. You put in the number first and then press the button you desire. If you are looking for the inverse trig function, you put in the number, press second, and then the button with the correct inverse sign that you're looking for. The best way to be successful in physics is to simply draw a picture and guess. But there's a catch. Scientists never really just guess. So guess actually stands for a method of problem solving. It's an acronym to help us remember everything that we must include. We have the givens, unknowns, equation, substitute, and solve. I'm sure you're wondering, but what exactly does each step of that problem-solving method mean? Well, the givens tell us what information we already know or what information is stated in the problem. Okay. Sometimes everything will be stated in the problem. Sometimes there's things we already know or along the way that we'll pick up, such as the acceleration due to gravity is negative 9.81 meters per second squared. May not be listed in every problem, but it's something that's true every time and doesn't need to be stated over and over and over again. Next is the unknowns. This is what the question is asking you to solve for. It can also mean, though, is there anything else that you must calculate first? A lot of times problems have multiple steps, but we have enough information with things that we already know and equations to use more than one, we can solve the problem in steps. So under the unknown section, if there's ever two things you have to solve for, you should list them both. The third step is usually the trickiest step, the equations. As you've seen in the handouts you've been given, you have several pages with lists and lists of equations. How do you ever know which one to use? Well, it's kind of like picking your shoes when you get dressed in the morning. You take your givens. What are you going to wear? Your unknowns. What shoes go best with that outfit? For a lot of outfits, there's more than one choice. But there's always going to be one equation that works better than others. Okay? So, equations are a lot like shoes. Most of them will work, but there's always that perfect pair. Our fourth step is to substitute. That means we insert the numbers you wrote down in the givens into the formula that we chose during the equation step. And our last step is to solve. We're just going to do the mathematics to find the answer. And we're going to be sure that it has the proper units. The last thing that we're going to cover in Math Boot Camp is probably the most important. It's an Algebra 1 review. We need to be able to work properly with equations so that we can get the right answer when we do the math. So, algebra can be summed up into 3 simple rules, if you will. Now, your math teacher may not agree with these rules, but they'll work for our purposes. The first one we have is the nail polish rule, or the weightlifting rule. It basically says what you do to one side of the equation sign, you must also do to the other. If you're going to get a manicure on your right hand, you should probably do the same to your left hand. Otherwise, you'll look a little bit weird. And boys, I know you don't paint your nails, so let's think about it about lifting weights. If you're going to do 20 curls with your right arm, you're also going to want to do 20 curls with your left arm. Otherwise, you're going to end up lopsided, and that just won't look right. So, when you're looking at an algebra problem, what you do to one side of the equal sign, you must do to the other. The second is the rule of opposites. If we are trying to move a variable of one side from one side of the equation to the other, we're going to perform the opposite function. So if we're adding x in order to move it to the other side, we'll subtract x. So let's look at a table of all of the opposites that we might encounter in this class. Okay, so this table works both ways, so let's draw an arrow to show that it's vice versa. Okay, so if we have addition, the opposite of is subtraction. If we have subtraction, the opposite is addition. Same thing goes for multiplication and division. Something squared and the square root. And then for a trig function, we have what we call the inverse trig function. So sine to the minus 1, cosine to the minus 1, or tangent to the minus 1. Okay, but let's add a few additional notes. Remember, squared is anything raised to the second power. And square root is the zigzag division sign. Okay, and then also for an inverse trig function, this is when you press the second key before you press a trig function on the calculator. And then our third rule of algebra that we need to use in this class is SADMIP. That's PEMDAS spelled backwards. So if we are solving for a variable, we actually have to do our order of operations backwards before we can plug it into the calculator and use PEMDAS forward. Alright, I believe algebra is something that y'all need a lot of practice on, so we're going to do 5 different examples. Our first example asks us to solve the equation y equals 1/2 gt squared to solve for t. So, first thing we're going to do is we're going to try and get rid of the 1/2. The 1/2 is being multiplied to the t squared. The opposite of multiply is divide. So I'm going to divide both sides by 1/2. Remember, we have to do it to both sides because it's just like only painting your nails on one hand or only doing curls with one hand. It ends up lopsided and that just doesn't work. Okay, and so we know that dividing by 1/2 is the same as multiplying by 2. So that gives me 2y equals gt squared. Okay, so the next thing we need to move is the g. G is multiplying the t. So, opposite of multiply is divide. So now I'm going to divide both sides by g. Okay, that leaves me with 2y divided by g equals t squared. The last thing I have to do is to get rid of the squared. And the opposite of squared is the square root. So I'm going to take the square root of both sides, which leaves me with t equals the square root of 2y divided by g. Make sure as you write your square root that it shows that all of that is under the square root symbol, which means if we were to put this into a calculator, we would multiply first, then divide by the g, and finally take the square root at the end. This is an equation that we will have to rearrange several times. I see quite frequently that students forget to take the square root at the end and stop too soon and get an incorrect answer. The next example we're going to rearrange two ways. We're going to start with v equals x over t, and we're going to solve for both x and t. So let's do x first. Okay, one thing about this equation is that we have t on the bottom. I don't personally care for fractions. To me, they get a little bit confusing. So whenever I'm solving a problem, I like to eliminate the fraction as soon as possible. We know that anytime there's something on the bottom of a fraction, that's the same thing as dividing. So I can move it to the other side by simply multiplying both sides by t. Okay. That leaves me with t times v equals x. That was the first thing we were asked to solve for. So that one was quite simple. Okay. Now we're asked to solve for t. Okay. It's much easier to solve for t once we have it solved for x because we no longer have that fraction. So it's easier to see what's going on. Okay, so if I want to get t by itself, I know that it's multiplied by v. So I'm going to divide by v on both sides of the problem. And that tells me that t equals x divided by v. Okay. A lot of times I will see students also use the little triangle method to solve this problem. In order to do that, you draw a triangle, divide it in half, and then divide the bottom half in half again. This line across the middle means to divide, and the line down the bottom means to multiply. So then when we're looking at our original equation, we're going to plug that into the triangle. Because x is on top of the fraction, x goes in the top of the triangle. Because v is on the left of the equal sign, goes on the left side of the bottom, and that leaves t to go in the bottom spot. So now we would just cover up whatever variable we're looking for, and then that'll tell us what to do. So if we're solving for t, we cover that up, and we get x divided by v. If we're looking for x, we cover that up, and we would do v divided by, or multiplied by t. Okay, so let's rewrite this neatly so that we can see all three versions of this equation at the same time. Okay, we have v equals x divided by t, x equals v times t, and t equals x divided by v. These are the first three equations that we will be using once we start to solve problems in this class. You do not have to memorize them as I provide you the formula chart, but you do have to know how to rearrange them and get them to this form. If you're not comfortable with this algebra, it may be in your best interest to work on memorizing these three equations that we just created. Moving on to the third example. This problem says f sub c equals m times v squared divided by r. The first thing I want you to point out is that this squared is only next to the v. So we can assume that there's imaginary parentheses around the v squared, and then we're only going to square the v which means we have to do that first rather than multiplying the m and the v together and then squaring. Okay? So then we have that divided by r, and we're going to rearrange this equation to solve for r. Just like on the last example, I'm going to eliminate the fraction first. So I'm going to multiply both sides times r. Okay. That gives me FC times r equals m times v squared. Okay. We know we're trying to get r by itself, and so if we look at the r, we see that it's now multiplied by f sub c. So I'm going to divide both sides by f sub c. And that leaves me with r equals m times v squared divided by f sub c. Okay, for our fourth example, we have a equals v sub f minus v sub I divided by t, and then asks us to solve for v sub f. Just like on the last two examples, the first thing I'm going to do is eliminate my fraction by multiplying both sides by whatever is on bottom of the fraction, which in this case is t. Okay. Those t's cancel out, and now I have a times t equals vf minus vi. Okay. Next is something we haven't seen quite yet. This is a subtraction. The opposite of subtraction is to add. So I'm going to add vi to both sides. That gives me a times t plus vi equals vf. Again, this is another example of an equation that we will have to rearrange quite frequently. So that's why I chose to do this example. Okay, let's do one more example before beginning today's worksheet. Okay. This example gives us sine of theta equals opposite divided by hypotenuse and asks us to solve for theta. Okay. So we see that on the left side, the only thing in front of the theta is the sine function. But how do we undo the sine function? If you remember from previously, we talked about the inverse functions. Simply all we have to do is take the inverse sine of each side, or sine to the minus 1. So that leaves me theta equals sine to the minus 1 of the opposite side divided by the length of the hypotenuse. Okay, to put this in a calculator, we would put in the number of the opposite divided by the number for the hypotenuse, and then press equals, and press second in sine. Okay. Now remember that this order of buttons is only if you're using the calculators provided in the classroom and some of the calculators that you may download on your smartphones. However, if you're using a larger graphing calculator like you're provided in math class, this is not the order that you would enter these operations. And that wraps up Math Boot Camp, aside from the worksheet that we have left for today. If you are having difficulties with any of the topics we've talked about this week, please make sure that you come in for tutoring before or after school or during lunch, whatever works best for you.